Hello everyone, welcome to Learnedze. In this session, we are going to discuss about one of the redundancy protocol introduced by Cisco, that is HSRP, Hot Standby Router Protocol. To understand the HSRP scenario, let's take an example of an organization. Let's say this is an organization network where this local area network is connected to this router R1, and through router R1 it will go to the internet and serve the internet. So for this, all the hosts present in this network, there is only one single point, that is router R1, through which they can connect outside to the internet. If this router R1 part fails, then all the hosts cannot serve to the internet. So it will be better for the organization to have a redundant link. Let's say there is another router that is connected to the switch SW1. So if this router 1 will fail, then router 2, that will be R2, can continue the communication. But in a local area network, adding redundancy link via switch is very easy. We can add different switches to the link and we can connect them. And if there is a loop forming in the switch, then we can enable STP, right? So adding a switch into the local area network for redundancy purpose is easy. But physically having two different gateways in the network, and we can configure only one gateway IP address into the host, that will be another challenge. Now let's see how we can add a redundancy link into the network. Let's say there is another router R2 we have introduced. So we have added another redundancy link into the network. Let's say here R1 is the active link and R2 is the standby link. So whenever R1 will fail, then R2 will comes into the picture. But for the host, it will be very difficult. Let's say the active router is working properly. At that time, all the hosts have to be configured the IP address of R1 as their default gateway. But when R1 will fail and this link will go down, then the R2 will be active, and at that time, in order to communicate to the internet, all the hosts, they will have to configure the IP address of R2 as their default gateway. So every time when the link changes, for host to identify whether there is a failure is occurring or not, and they have to change the default gateway address, at that time it will be very hectic for all the client, and also it will not be possible if we have a large number of hosts present in our local network. To solve this problem, it comes the picture of FHRP, that is First Hop Redundancy Protocol. This FHRP concept helps to get redundancy link in our default gateway. And there are three types of this FHRP redundancy protocol. First one is HSRP, number two is VRRP, and number three is GLBP. So HSRP is a Cisco proprietary protocol, so you can apply HSRP only in the Cisco devices. If there are other vendors mixed into the in your network, then you cannot use HSRP protocol. VRRP protocol introduced by IETF, that is Internet Engineering Task Force. And GLBP is again a Cisco protocol. But here in this session we are going to discuss about only the HSRP concepts and two versions of HSRP protocol, that is version 1 and version 2. Now let's check how an HSRP works. HSRP works in a very simple logic. Here these two physical network or these two physical device will act as one single virtual device in the network. That means for all the hosts, after configuring the HSRP in router 1, R1 and router R2, this will act as one virtual device besides having two different physical links. So by using HSRP, all the hosts, they will configure neither the R1's IP address as the default gateway nor the R2's IP address as the default gateway. That means by using HSRP, we can configure one virtual router which will have a virtual IP address and also the virtual MAC address. So by using this virtual IP address and virtual MAC address, we can add the redundancy link into the gateway. So HSRP mainly operates in active and standby mode. Let's say this interface is in active mode and this is in standby mode. So whenever the active will fall, automatically through the virtual router IP address, virtual IP and virtual MAC address, the connection will shift to the standby. So whenever the active will fall, standby will become active and the host can communicate through it. Now the question is, what we will gonna configure as a default gateway over here. So here in all the hosts we are going to configure this virtual router IP address that we are creating by using HSRP protocol as the default gateway to all the hosts, so that every time whenever the path changes, the physical router changes, that time they don't have to configure again the default gateway. So the host can have an unchanged default gateway in its internet card, and they can communicate with the internet easily. Now let's check this process in Cisco packet tracer scenario. Let's take this scenario where we are going to configure the HSRP. So here in the first step, that is step number 1, we are going to configure the loopback IP address, loopback 0, in both of the routers, router 1 and router 2. So that the internet IP address 1.1.1 will configured as an loopback address into the router, because we are not going to configure the cloud and all over here, right? Then in the step number 2, we are going to configure this router R1 as an active by using HSRP and router R2 as an standby by using HSRP command. Then in the step number 3, we will take one of the hosts from the our local area network and we will ping continuously from that host to the internet IP address, which is 1.1.1.1, right? Then after pinging, what we will do, we are going to shut down this router R1 and we are going to look after the amount of time that is required to come this standby mode to an active mode when the active router is fails. Then after all that, in step number 4, we are going to configure the version 2 configurations. Now let's go to the step number 1, that is let's configure this loopback address in both the router R1 and router R2. For that, let's go to the router R1 and let's go to the global configuration mode and let's go to the interface loopback 0 and add the IP address, which is IP 1.1 IP address 1.1.1.1 and the subnet mask is 255.0.0.0. Okay, then enter the end command. Again go to the router R2. Here also configure the same thing. Now let's configure the router R1 as an active mode and router R2 as an standby mode. For that, let's go to the router R1 and let's go to the global configuration mode. Then let's go to the interface G0/0/0, which is nothing but the router R1's default gateway interface. Here we are going to configure the HSRP by using standby command, standby, and we have to write down a group number. So let's say standby group number 10, and we are going to add the IP address, which is 192.168.1.1, which is nothing but the virtual router's IP address. So that this physical link will act as an virtual router, which address is 192.168.1.1, and press enter. Then again we have to make it active mode. For that we have to go to the standby group number 10. Then we have to add the priority value as the highest. So here I am adding the priority value as 110 and other routers will be less than 110 priority. Then again we have to go write down the command standby group number 10, then pre-assumption option, so that whenever there is a failover occur and after failover, if this router R1 come back to the network, then it will maintain its previous state, which is an active state. So that's why we use this command. Now let's go to the R2 and configure the same thing. Group number 10, pre-assumption. Here I am not configuring the priority value because I want to make this router R1 as an standby mode, not as an active mode. So that's why the default priority value is been there. Now let's check the connection whether we have successfully achieved the HSRP or not. If a link fail, let's say router R1 which is acting as a active router, if this router R1 will fail, then whether this host can communicate through router R2 or not. For that, let's go to this PC 192.168.1.5 and here let's try to ping first to the internet IP address, that is ping 1.1.1.1. As you can see, we have successfully communicated with the 1.1.1.1, which is nothing but an internet IP address. Now let's ping that internet IP address continuously. And now let's go to the router R1 and turn off this gigabit ethernet 0/0/0 port. For that, let's go to the router R1 and again go to the global configuration mode and go to the interface Z 0/0/0 and write down the shutdown command. As you can see, during this time the it is not getting the internet, so one packet has been failed, right? Similarly, another packet is failed, one more packet will be failed, and now after that it is getting the packet reply from the internet. So how it is getting the packet reply? It is getting the packet reply via router R2, as you can see, because router R1's link is down. So around 3 data frame will be dropped in this scenario. Now let's go to the router R1 and let's check this HSRP by using the show command. For that we have to write down show standby brief. As you can see, this was in initialized state right now because this is down, right? If I go to the router R2 and if I check the same command, that is show standby brief, as you can see, currently this is in the active state. Okay, now again I will go to the router R1 and I will turn on the interface Z 0/0/1. For that, let's go to the configuration terminal, interface Z 0/0/0 and write down the no shutdown command. So this time this router R1 will come to its original state, which is nothing but an active mode. So now this status is green. As you can see, this has changed to standby to active. Now we can check by using the show command, that is show standby brief. As you can see, this router R1 is in group 10, priority value 110 and is in active mode right now. Okay, if we go to the router R2 again and if we want to check the router R2's standby mode, as you can see, it is in the standby mode right now. Okay, then we can check the other things by using show standby command. So here you can say that this is in the standby mode and it has a virtual IP address of 192.168.1.1 and this is the virtual MAC address. So this virtual MAC address will be same for both router R1 and router R2. If I go to the router R1 and if I do the same command, that is show standby, as you can see here also the virtual MAC address is 0C07AC0A. Similarly in the router R2 also the 0C07AC0A is the MAC address. And here one more thing is there, hello time is 3 seconds, hold down time is 10 seconds. So this is very important for the HSRP point of view, this hello time and hold down time. So there's two timer that HSRP work on, one is hello and another was is hold time. So hello is of 3 seconds and hold down timer is of 10 seconds for HSRP version 1. Okay, so what is hello time? Hello time is the time that is used for this standby router to listen to the active router. That means from every 3 seconds this active router used to send hello messages and this standby router used to listen to those hello messages. And in HSRP version 1, these hello messages are sent by 224.0.0.2 IP address, which is nothing but a multicast IP address. And in HSRP version 2, these hello messages are sent by 224.0.0.102 IP address, which is also an multicast IP address. Let's say this standby router is not getting the hello messages for 3 times. So 3 cross 3 second, which is equal to 9 second. So approximately 10 second, if it is not getting any hello messages from the active routers, then the standby router, it changes its states to the active state. So it will take around 10 seconds for a standby router to come to its active state. Now let's configure HSRP version 2 in both router R1 and router R2, and let's see how we can reduce this time, hello time and hold down time by using HSRP version 2. Now let's go to the router R1 and configure the HSRP version 2. For that, let's go to the global configuration mode, config T, then interface Z0/0/0, and here we have to write down the standby command. Standby, that is here, if we put question mark, as you can see, the version, HSRP version. For that we have to write down the version. If you put question mark again, you see two versions are available, 1 and 2. So this time we are going to configure this HSRP version as version 2. So I have successfully configured the HSRP as a version 2. Similarly, the router R2 has now the HSRP version R1. So the version mismatch. For that, what I have to do, I have to go to the again router R2 and we have to configure this HSRP version 2 command. For that, again we have to go to interface Z0/0/0 and we have to write down the command standby version 2. So now the both routers are in the same version, HSRP version 2. Now again go to the router R1 and we are going to change the hello time and the hold down time. For that we have to go to the, we are already in the interface Z0/0/ mode. So here we have to write down the standby, then put question mark, as you have seen the timers. Okay. And we are going to use the group number 10, and group number 10's timers. What are the timers available? So 12254 timing is available, but in only in seconds. But in real switches you will find fractions of times also. Here in this scenario we will have to configure only in seconds. So let's configure 1 second for the hello time. Okay, and for the 2 second for the hold down time. Okay, so it will be very less compared to the previous. Okay, for that we have to write down this command, standby 10 timers 1 space 2. Okay, so we have successfully configured the timers. Again go to the router R2 also. Here also we will change the same thing. For that we have to write down the standby group number 10, then the timers. What are the timers available? Timers 1 for hello second and 2 for the hold down timer. So this is done. Now this time let's check the failover time. So we can check the timers by going to the routers. That is, let's go to the router R2 and let's write down the command show standby and press enter. So here you can see that yes, this hello time has changed to 1 second and hold down time has changed to 2 seconds. This is a HSRP version 2. So we can check the router's packets, the hello packets, by using the debug mode. For that, let's go to the router R1 and let's use the command enable, then use the command debug standby packet, so that we can see the hello packets. As you can see, by each second it is sending the hello packet from the routers R1. Now it is sending the hello packets in 1 second interval. Now turn this off by using all command. So all the debugging has been off. I hope you have understood whatever we have discussed in the packet tracer scenario. So there is an example. You can write down the commands. Thank you for attending this session. If you have any doubts and queries, let me know in the comment box. And for this complete CCNA course, you can contact us at info@learnedze.com. Thank you.